Very good evening once again to all the tech enthusiasts gathered here today. We were excited to kick off the second session of the AI Bootcamp 2023 series focusing on retrieval augmented generation and fine-tuning large language models. Before we dive into our session, let's express our gratitude to our esteemed sponsors. Has played a pivotal role in making this bootcamp possible. We are also grateful for the expertise and support of our AI expertise partner, Sound 24/7, our mentoring partners, 99X and Nagaro, our industry collaborative partner, SASCOM, Jusa, Trace and Axler, our judging partner, LSCG, and our venue partner, a AAA student branch of ITT. We extend our gratitude for their invaluable contribution making this event possible. Now, before we proceed with the session, let's take a moment to appreciate the significant role played by our official trailblazing partner, IFS. We have a specially curated video to showcase their incredible contributions to the field of artificial intelligence. Let's start the tape.
IFS is powering big enterprise, big ideas, and big change. With technology that enables companies to innovate and grow. With unparalleled industry depth that provides a way to create value by joining the dots and how companies engage with their customers, empowering their people and use their assets so that they can deliver when it really matters at the moment of service. Touching our lives and improving the way we do business across the world.
From the moment we wake up.
To how we travel.
To the business we do.
And how we care for our world.
IFS is leading the way in empowering thousands of the world's most progressive brands. Let us help you be your best.
At the moment of service.
A round of applause for IFS, our official trailblazing partner, for their incredible contributions to the field of artificial intelligence. Now, to give you a glimpse into the expertise that Sound 24/7 brings to the table, we have a specially curated video for you. Let's start the step and get inspired by the cutting-edge AI innovations from our AI expertise partner, Sound 24/7.
We are Zone 24/7, an advanced technology and research center established and headquartered in San Jose, California in 2004, specializing in offering end-to-end technology consulting and engineering services encompassing both hardware and software. Our sound research and development background means that we are constantly developing leading-edge technology solutions ahead of market needs. Our ability to meld hardware and software solutions places us among a handful of companies in the world with the ability to do so.
Zone 24/7 has continued to show phenomenal growth since its establishment, which has pushed us to be a pioneer in the IT industry. We work towards our vision of enhancing the emotional experience of everyone we touch, be it our customers or employees who are part of this great organization.
Our global outreach is empowered by local talent. We are the industry leaders when it comes to hardware and software, catering to an array of industries and providing state-of-the-art products and solutions for global customers. Zone 24/7 is led by a tech-savvy leadership focusing on technology innovation, and our direction is shaped by mentorship and guidance. We are an organization with autonomy and empowerment, which brings creativity and innovation to our day-to-day lives.
We have a diverse range of products and solutions being developed under one roof, bringing in major technologies and diverse tech stacks into our work. We are the industry leaders in a multitude of technology domains, including software engineering, artificial intelligence, machine learning, big data, robotics, embedded systems, and many more. We are also a pioneering leader in software quality assurance and test automation, striving towards making us a center of excellence in software quality assurance. Zone 24/7 has the luxury of a work culture that is collaborative, friendly, caring, and supportive. Both our culture and environment build camaraderie among us.
Our culture has inbuilt learning and development, defining us as a learning organization where knowledge and learning are highly valued. Zone 24/7 is a place where one can learn, grow, and achieve a great career.
We have a mentoring and coaching mechanism to support individual career growth. We follow industry best practices in managing talent and keep a high focus on the potential for growth and personal development.
Your aspirations are important to us. We provide opportunities to create, innovate, and influence our global products and solutions. You will be able to see the results of your work in a global environment and grow in a career aligned with your expectations and potential. Providing opportunities for intellectually demanding and emotionally rewarding work. We are Zone 24/7.
A round of applause for Zone 24/7, our AI expertise partner, for their incredible contributions to the field of artificial intelligence. Now, let's introduce our distinguished speaker for today's session. Our speaker, Mr. Samudra Kanankearachchi, the Director of Technology at 99X, brings over 18 years of seasoned experience to the table. His leadership spans offshore teams showcasing expertise in Microsoft full stack, large language models, AI technologies, GPT, and OpenAI. With a background collaborating closely with premier independent software vendors in Norway, he brings a novel understanding of industry challenges, specializing in GPT and AI technologies. He leads their adoption and integration, driving innovation and delivering outstanding solutions. Without further ado, let's delve into the world of retrieval, augmented generation, and fine-tuning large language models with Mr. Samudra Kanankearachchi. Over to you, Mr. Samudra.
Yeah, thank you very much. Let me share my screen. Just can I see my screen? Right. Hope you can hear me clearly. I'll just share myself in the video for a few seconds. Thereafter, I will switch off the video. So better for bandwidth and everything. Hope you all can clear me. If someone can confirm sound, screen, and everything okay. Yeah. Okay. Right. Okay. So good to see a lot of people joining Sunday afternoon, Sunday evening. So this is going to be in this session. I'll be talking about both retrieval, augmented generation, and also a little bit about different architectures, concepts, and how you build this kind of open AI integrated solutions. So I will try to keep balance between the coding and the overall picture, because I think what matters within this short period. So I'm planning to give you some good understanding. I think since you all are preparing for this hackathon, it's also really important to understand the overall picture of this GPT-based, AI-based architectures. So I will try to cover both areas, one from the tools perspective and the code perspective of view, and also overall architecture and different building blocks that you can use to build this kind of AI integrated architectures. So my background, I think you got enough introduction about my background. So if to say maybe last 1 year or so, I have been very deeply integrated with developing systems on top of generative AI. So I had this classic AI background, but if you look at last 1 year, purely it's yeah, I think it's immediately after this ChatGPT. So I have been spending a lot of time on this. So I have a very good understanding about these underlying architectures and models. So I'll try to share my knowledge and experience. So it's clearly, if you look at what has happened in these latest conferences, like Microsoft Ignite, then OpenAI developer conference, and also this GitHub conference. Very clearly, you can see that all their CEOs, CTOs now talking about age of co-pilots. So it's age of co-pilots, it's happening, and partially it's happening. And I think rapidly it will change the way we work, way we code, way we integrate products, the way we design software architectures. All these things will change. So a lot of people believe that AI will replace workers, but the concept behind Copilot is completely different. So it's designing systems that you can sit side by side with human and assist them. So it's just like I can remember, like many years back we were talking about pair programming, and it has been improved a lot. Like instead of me thinking whole design and development, so we have this practice of doing developments together, side by side. So if you apply the same concepts in this Copilot, so Copilot is just like your buddy. So designing systems just like your buddy, but make sure that it will help to improve your productivity, and also it also will help to run this system. Like, I mean, as humans, you need this cycle of works. For example, I can bring examples. So you work 8 hours. but on night you go to sleep, right? But these co-pilot systems, one of the advantage, these co-pilot systems, so these systems will keep thinking on behalf of you. So it never stops, right? So that's the ultimate idea, like how you build a buddy or assistant who can work side by side with you, right? So these systems will not replace, basically. And one of the very common co-pilots today, you can see ChatGPT being very early prototypes of co-pilots that we are talking about. So maybe it's just text-based at the beginning. It can generate a lot of textual contents using natural language processing techniques, but the amount of other aspects, like I'm not talking about the today's context, but how it has started. So you can see that it's text-based started with text-based primitive copilot, but gradually now you can see where they are directing towards, right? But the problem with these copilot systems like ChatGPT, so they've designed and fine-tuned using large volume of text or video corpuses, but which really don't have your internal knowledge. If you take your organization, right? So your organization has its own knowledge. Yourself, you have own knowledge. But if you look at these large language models, they have massive knowledge, but those are not really reflecting your internal knowledge or your local organization knowledge. So there's a need for you to develop a system, or there should be a way to you can integrate your own knowledge into these models. So that's where you bring this retrieval augmented generations, right? And also one other rule I would like to add here: if you have any questions, please write it on the chat. If at any point, if you are not clear on anything, you can actually raise your hand, and you can let's try to minimize like voice conversations. Probably you can have your own questions to chats so that I can answer them while I'm doing it. So in the screen, you can see I have shown an example where, so you ask about a tour plan for your trip. Say you are planning a trip at the end of the year, and you go and ask ChatGPT or Bing about tour plans, and he will recommend certain things based on their knowledge, right? But in this case, he will give good suggestions because he has seen a lot of knowledge out there in the world, but it's not very much tailored to your own context or your own interests, right? So that's where you need to like go and say, okay, this is I would like to this is my interest, and these are the places I would like to visit, and what are the activities I can perform. So you have so much of detailed questions that are not directly addressed by the globally available GPT models. So let me show you one example what kind of things just listen to this video.
Confirming a reservation for 4 on Delta Flight 1465 at 3:45 p.m. Have a great visit, Dr. Green.
So to recap, Emily, you're looking for a loan of $5,000 to expand your business. Let me run that through the system. Good news, Emily. Your loan has been approved. Let's talk again in Q3 about your needs for next year.
Hi, Tom. Congrats on completing the logistics onboarding for speedgo.com. See you at your next session. Have a great weekend.
Here's the data you were after, Joanna. Last quarter's sales year on year. Would you like to see a 5-year breakdown?
Yes, that's right, Alex. All your test results came back negative and your other diagnostics look great. I'm scheduling you for another checkup in 6 months. DID's AI assistants, the future of customer interaction.
Yeah. So the applications that you have seen in these videos, those are the type of applications we are talking about as copilots. So if you look at our applications in the past, someone would say, okay, say our application should have complex UIs, and there should be set of buttons, and there should be places where we can input. So those are the applications that we have seen in the past. Doesn't matter whether it's a mobile application or web application or very classic desktop applications. You can remember that those era we had very complex UIs where even user don't know what to how to use that application, and you need a very complex training or introduction for someone to use that application, right? But these natural language models will change the landscape. Now, when you see that video, you will even find it really hard to realize whether there's an application there, right? So probably on the real world, you may not see something like a physical application, but context based, it will be a voice input, it will be a notification that that comes into your application, comes to your mobile phone. So those are the changes that will happen with this augmentation. And so we have to build these building blocks to support these new scenarios. So what you see on the screen, it's internally we called it Optimax AI. But what we have done is we have developed a large number of building blocks where we can plug these different components together, just like how we plug Legos when building prototypes. So each these individual building blocks, they are capable of handling certain natural language scenarios. For example, let's say this Optimax Q&A, it's capable of handling. You can take any text content. It could be a book, it could be a web document, it could be a PDF. So you can use those kind of large text content, and you can keep ask questions from those content, unstructured content. And this Optimax Assist also similar. And these recommenders are also pretty much very powerful concept. Traditionally, we have been talking about this content filtering and collaborative filtering kind of recommendation engines, where your context is limited. With GPT, now you can give like context-based inputs, and you can rich guidance what to be recommended, and you can do a lot of personalizations on the recommendation. And the extract and explain also very powerful another concept, where you can extract, let's say you have bill. It can be your doctor's prescription. It can be your banking statement. So from their unstructured format, you have a lot of structured content inside the unstructured documents. So which will be a very powerful case where you can extract different business entities like your expenses. It could be your drug prescription, drug doses. So you can extract this very valuable information. That's also a retrieval mechanism. And this knowledge graphs, knowledge graphs. In organizations, you have large volume of unstructured data, things like CVs, and it could be your wikis, your documentation, and these kind of contents has very rich insights. So if we can connect these different isolated document structures and create a graph kind of thing where you can talk, like we can query and get valuable insights. Let's say if you are in a situation, you wanted to find certain set of people with certain skills, so you can query unstructured CVs, and if you can find out people or things like that, you can build using knowledge graphs. And also on the other side, so when you are dealing with this kind of external open AI kind of data exchange, the data security and safety is a very valuable under international context like GDPR. So you have to have kind of platforms where you govern the security, personal data management. So those are also part of this platform. But the reason I brought this total solution here, not to talk about the Optimax, but these are the key building blocks that you could find when you are designing a modern Copilot application. That is very important to understand. I mean, as maybe you are at very last stages of your undergraduation, maybe you are very early part of the industry, but when you are designing a solution using open AI, so these constructs, you have to have a very thorough understanding of different use cases that you can you do using this open AI building blocks. So that's why I brought this whole concept. So these pillars are very important you to understand. So you will have to use different technologies, different tools, different languages to in achieving this, but these pieces will remain in your application. Say if you want to migrate, let's say, I mean, this is the very common cases that we arise in the industry. So you have these traditional applications that are written using let's say my underline, you have microservices, you have CRUD operations, you have data access layers, you have this rich application UIs. And we have cases where we wanted to transform these traditional applications into natural language based applications. So you need to understand how you do the transition and what are the different building blocks and what are the different concerns that you have to look at. So that's why I brought this whole holistic picture. So in such a transition, you may need many of these building blocks. So you don't have to use these tools, but you have to look for the similar pieces, and you have to build a completely different way of thinking. Because traditionally, if you ask a programmer or if you are as a traditional architect, so how do you build your software architecture? He may come and say, okay, I build microservices and I try to maintain very thin slices end to end, and then we plan these different layers and slices of the architecture, and we follow well architecture framework of Azure or AWS. So you may have different explanations, which is kind of now you cannot think on the same line. If you are to design a new OpenAI kind of architecture, so you have to get rid of this traditional thinking process as your first step. So you have to understand what are my key building blocks in developing a natural language based application. So that those are the questions you have to ask yourself. Because I mean, I will give you very clear examples. Traditionally, if you take AI, there you talk about, you select a certain niche use case, which is a very small part of the organization, and you try to apply AI for a very specific use case. We call them narrow AI, right? But if you take what's happening today with these co-pilot systems, so there we talk about, can we automate workflows? Can you automate entire business silos? So now we are trying to touch actually larger part of organization processes using modern AI. So completely different way of thinking. Traditionally, AI, I think it's a very I mean, you have to have very specialized people, and you pick a selected part of the organization, and cost is too high. So it's a completely different context how it has been AI in the business. But if you take AI today, so probably, I mean, 2-3 years down the line, the whole story will be completely different. In a way that you never even talk about this traditional programming. So we have to look and see where it will go. But I predict that is where we directing. So people like you, when you are coming to industry, just like when we came to industry, we were talking about databases, services, microservices. So it's the traditional architectural pattern. At that time, it's modern. But today, when I look at it, I would say it's a traditional architecture patterns. But when you come to industry now, so you have to have a very clear understanding. These will be your building blocks, right? So you have to see that transition, right? So that's why it's important. I took a little bit of time, but because I wanted you to have a good grounding here. That's why I spoke a bit more in depth about this. So if you have any questions, just throw it out. So when I am following up on the chat, I'll try to address them. So then this next part. So underline all these co-pilot systems. Large language model plays a massive part, right? So, I mean, when you say large language models, so there are two ways you can look at this. So one way to look at is to look at deep understanding of the underlying transformer-based architectures. Right, so you can go very deep into the neural network and try to understand what is happening in these large language models, right? The other ways is just like, okay, we don't care what the large language model, so we care about the application use cases, right? So the other side is you just, okay, we have a something called large language model, and it has its own APIs and interfaces. If you integrate to your application, so it will work, right? So both two extreme ends are, I mean, for industry, it's useless, right? I mean, for academics, it makes sense to go deeper into these models and understand how this neural network works and how these weights and what is the difference between these different models. That's a different ball game altogether, right? But you have to have a very balanced understanding. If when you say large language models, you need to know about some different pieces of this large language models, right? So that's why I brought this picture. So underline, it's very clear that there's a massive neural network, right, which is trained with a large volume of data. So if you take latest models, I think it is trained up until June 2020, 2022, right? So it has massive volume of data trained into a neural network, and that's there, right? And it has large, I mean, these numbers will differ, right? So now they are not very transparent about the size of these models, like how many layers, how many attention heads, and what is the neuron architecture and all. So you may able to find these internal parameters, but here what you need to know is 96 layers means when you given a question or when you give an input to do a certain process, it can break the whole question down into 96 layers. So forget about the numbers, large number of layers, and you can do drill down detail analysis. It's just like okay, when you see a person on the first layer, you may see a wireframe of a person, right? Then you keep adding different features and you will say, okay, this is a girl and this is a boy. And then you add different colors and a lot of details in hidden layers, and you process the output, right? So when you have large number of layers in such a neural network, the process you can perform is massive, right? So it's a massive layer. On the other hand, you need to understand this concept of attention heads. So if you take any large language model, having 16 attention heads means for a given input, you can process at multiple dimensions. That means you can look at this using 16 different dimensions. So it could be like, let's say, when you ask certain questions, you can check the sentiments of the input. You can break it down into pieces. You can control the attention of it. You can break it into smaller tasks. So that's why you have this attention layer, right? So one of the first thing when you get a input, let's say, I can explain it like this. Let's say if I am given you a task, I can say design a system, let's say sales organization, for a sales organization, right? So at a very high level, if you say something like that, you will find it very difficult to grasp. So it can be a vague statement. You say, okay, design a system for sales organization, right? But in such a complex task, you can break it down into different pieces, right? You can say, how do I design a different service of this product? And how do I design the front end application? How do I design my storage structures? So you can break the whole problem into multiple smaller pieces. So your attention become very high, and your understanding about the problem become so high, right? So when you have large, in that case, you can see that when I am split it into multiple pieces, those are the attention mechanisms, right? But in a similar context, when you given some input, natural language input, if the input is so complex, you have the option of breaking down into pieces, and you can do it parallelly, and even you can build different relationships and things like that. So you give better focus to your prompt. We call it prompt engineering, right? So the way you work with this model is prompt engineering. And then the prompt engineering, if the prompt is too complex, so you can break it apart and you can analyze that in isolation. So you can, before you give the problem to solve, you break it and you can bring the correct attention into the prompt. So that is what attention layer does, right? And also this very important to understand the relationship between the this parameter concept and the brain synapse and neuron concepts, right? So having large number of parameter means when you have multi-billion parameters on a neural network, the amount of information that you can train into the model is so high, right? So that's why you have this large billion parameters. So later, if time permits, I will talk about, I mean, there are arguments about smaller the better, larger the better. So there are trade-offs, right? It's just like you can have a large brain. Of course, if your task breakdown ability and your attention is vague, then those models are not effective. So it's not that larger parameters are always good. So that is not the way you look at models, right? Hope this gave you a very high level. I mean, this is a very higher level concept. So if you drill it down into details, you have a lot of things. But I think this level of understanding is good enough for someone to start with operating with these kind of large language models, right? Just a question for the organization committee. Can anyone just follow up on the chat, because when I'm doing this presentation, I lose the track of chat. So if there's anything essential, any essential questions, someone can prompt and just ask it. So do the moderation. So right, okay, yeah, I think up to this point, I was just very elaborative about the whole context and the high-level parameters of the large language models. So this here onwards, I will try to articulate the whole architecture of these kind of co-pilots and models into different levels of architectures. So if you take large language model in isolation without having application, so what you see as ChatGPT is an application. It's not a large language model, right? So what you have behind ChatGPT is the architecture. So by just looking at how ChatGPT behaves, you cannot exactly predict how large language model predict, because you write a layer on top of this large language model to make ChatGPT a comprehensive copilot, right? So if you take a raw large language model, so it is nothing but a neural network with slight language understanding capabilities, where you have ability to give prompts as inputs, and you can write a simple application to interact with LLM through a API, right? If you take this whole the lowest LLMs without any additional layers on top of it, I would call it a level 0 architecture, where you can directly interact with the LLM using prompts, right? So that's level 0. And there you control the behavior of large language model purely using prompts, right? And these additional inputs, let's try to compare it with the human. I mean, this is again also very complicated topic. Does actually LLMs reflect the real humans memory architecture? Clearly no, but at least people try to mimic it. A lot of explanations and abstractions, people try to compare these two, right? So I also will do such comparison, but it's very clear, I'm very clear those are two different things, but it will make yourself very easy to compare, so you get the concepts right? There's no other reason I should compare a large language model or this kind of co-pilot with a human. So that's unfair on human, right? But it mimics certain parameters. So if you are designing a co-pilot system, to any business, so you have to bring something called a persona. That means, so if you are bringing a large language model to a business, you have to make sure that your model controls and it follows the business rules and business ethics and guidelines, right? So that is what the chat. I mean, when you bring ChatGPT for in reality, so they have spent, I think it's more than 7 to 8 months in training human alignment layer. So you try to give different prompts, and you inject certain traits of human to model, so that you are answering and giving recommendations for human and for businesses. So otherwise, even you can train a large language model to perform something bad, really bad, right? Because imagine if you change good and bad, and if you train the model in a destructive way, so you can add that. I mean, just like in Facebook, you see how memes ruin the society, right? If you look at Facebook today, you can see that how much pollution that happens from the bad memes, right? Similarly, inside a large language model, so you can do that. So that's why you have to bring this persona into large language model and say, okay, you are an assistant to design to cater customer support, and you have to follow these ethics, and you have to make sure this you use this language, nice language, and you cannot go over tempered. So you can do all this human alignment activities inside this persona. And also the instruction, so also we call it I'll show you how we do it separately. First I'll explain this. Then the next thing is, if you take a large language model itself, it doesn't have a memory or a long-term no, not even short-term memory. If you give 2 prompts, let's say if you ask 2 questions, so those 2 questions are independent, so those are not linked together. That means it doesn't hold any memory. So if you take a large language model at its raw, right? So but if you write you can write application to have a memory, and then that is what you see in ChatGPT. If you take ChatGPT session, so you can see that it understand your history, and it maintain your previous conversations, so it has your short-term memory. And it doesn't also have a long-term memory. Someone could say why neural network is your long-term memory. So that is not right. So long-term memory, I am referring to the knowledge, internal knowledge of the organization, not the global knowledge or the neural network. But in our memory also, like let's say you have your images stored somewhere, you have your books and your study materials. So those are your long-term knowledge, but which is not inside your brain, right? So certain things are inside your brain, but for you can have your long-term knowledge outside your memory, but you can retrieve it and plug it given the context, right? When you have an exam coming up in next week, so you start your study materials, right? So you bring your long-term memories into your short-term memory so that you can face your exams, right? Similarly, for these LLMs to operate in business context, so you have to have this long-term knowledge and also short-term memories, right? So this is a very important part. Otherwise, I mean, this is very important for you to get the what do you call that, the proper attention. Let's say if short-term memory is always important to achieve the speed. Like, let's say if you are performing on a certain task repeatedly, so your short-term memory should be always full with information related to immediate access. So that is the way you make sure that you perform things actively in a faster manner. Imagine your short-term memory is always getting full, then you will slow down because you have to access your long-term memory all the time to perform the short-term memory task, right? So those two differences you have to understand, right? So you can see this even in your traditional systems, and also you can see this in your brain architecture, right? So when you have personas, instructions, LLMs, memory, knowledge, so this is good enough for text generation, right? So if you are only performing text generations, right? So you can have it like this. But a large language model, just as a text generator, that's good for generating stories, generating I don't know, whatever the answers. So it's only text based, right? But if you want to perform something, let's say you want to I mean, based on let's say a customer call your support center and say, I want to check my bank account balance, right? So that information you don't have in any of these memories, but that is pretty much external, and it is inside your backend databases, right? Banking backend databases. Probably you have to call either API, right? Probably you have set of APIs where you can invoke on your backend systems. For that, you have to integrate tools, right? So this is just like let's say in a brain, when you have some thought process and you have to lift your hand, right? So that's the action part, right? So if you want to, let's say I want to lift my cup, right? So that to drink a tea, so that thought happens in the brain, right? But if you have to do the action, it has to wire into your external. So this tooling part performs that. Is it clear so far?
Yes, sir.
Right. Okay. Right. Okay. Yeah. If you have any questions, just drop me. I think this is the whole idea behind this LLMs, and this is the so if you take level 0 architecture, none of these, like this red color crosses, those are not there, right? So let me take you into some. Let me see. Okay. Okay. I can take one example. So I will not go into practical level for all the applications. Few things I'll show you practicals, but I will try to cover most, so you will have the holistic understanding. So if you take this for example, right? So this is a Asia OpenAI Studio. There are you have something called Playground, where you can do like now, just like OpenAI, these models are exposed through Asia OpenAI services. So I think you are familiar with Microsoft cloud platforms, right? So this is a tooling that have given to try out. This is different play. So you can basically prototype and just get an understanding how it works, right? So this system message, right? Right. So here your role, it says we are going to design a customer support agent which can answer queries about Xbox customer support, right? So you can ask different questions about Xbox, right? So the system message, it is the overall objective you wanted to achieve from this agent. So in any this kind of assistant, you have three type of messages. One we call system message. This is the one which try to like direct you what you want to achieve from this chatbot. Simply you can assume this is a chatbot, right? So I will explain differences later. So you want to design a chatbot which could answer customer support queries about Xbox, right? And these examples, this is the conversation modeling between the AI and the user. Like when you have this kind of system, you want to model and say, this is the way I want to have this conversation build upon, right? So you can give much examples as possible. So here you don't have to train with all the type of conversations. Let's say that is the difference between the traditional machine learning and machine learning training models. Here we use something called one shot, few shot, and many shot training, right? So because these large language models are trained with millions of scenarios, so they know about these scenarios beforehand, before we train them. But what we are doing is we are realigning these models to fit for our specific purpose. So you don't have to give a large number of examples to train this, right? So here we train sample examples on how you want to have the communication. Let's say if you have to have wanted to have a very pleasing tone between the customer and the AI, that you can model using examples, right? Even you can do it in the system prompt, and you can say, okay, you have to be polite, you have to be I mean not arrogant, and you can have all these kind of instructions into this system message so that he will understand, these models will understand how you want to build it. So once you build it, so now you can perform a chat, right? So this is a very simple level 0 architecture where you touch only the input and the prompt and the LLM. That's all, right? So you don't have any integration to your backend, no integration to your long-term model or a short-term memory. So nothing is there. So this is one example of level 0 architecture, right? Right. Okay. Let's go to. So this is now so far. I'm not sure whether you understood the concept of RAG, retrieval augmentation. So in this case, this few shot learning and one shot learning in this, I mean, level 0 example, right? RAG can go into different levels. In this level 0 architecture, the knowledge that that was not there in GPT model, so those are trained using examples in this case. So this is the augmentation part, right? So that our own personalized knowledge was not there in the GPT, so we augmented it using samples, few shots, right? So that is kind of a level 0 RAG use case, right? So I will directly jump into, let me see. So you may see not a classic presentation, right? So I will go back and forth in examples. So sorry for that. I don't have a only presentation mode session. Let's see. Okay, I'll open another chat window. Right, I'll go into ChatGPT. Right. Okay. So I'm going to give you another example. So this time I'm going to probably these activities I am doing here, you will not be able to do unless you have a pro version of ChatGPT. So you have to have a pro version. But let's see this, right? AdventureWorks. If you have heard about this, AdventureWorks is a sales. It's a e-commerce database, a prototype database from Microsoft to demonstrate reference Microsoft architecture. So it has around 20 years of history, which has been used as a reference database for different architecture evolutions. So I think if you take 2000, when they introduced .NET architectures, they used the same database. So I'm going to use that database, and I will ask, do you know about AdventureWorks, right? So yeah, he will know about AdventureWorks because this is available in their Microsoft documentation, and there are several wiki articles, prototypes. It's all over the net. So when they train this, they had that knowledge, right? And now what I will do is I have a let's see, right. Now I said OpenAI is traditionally, these models are designed for text manipulation, and they are really bad in mathematics or mathematical modeling, right? So if you directly go to OpenAI GPT 3.5 model and try to solve, let's say, very complex mathematics or things like Fourier series, so this real mathematics or real analysis problems, it will struggle because it doesn't have any knowledge about this deep understanding about the mathematical solution solution building, right? So I have this comma separated data set which represent AdventureWorks data set, and I will drag it and drop it to this ChatGPT surface, right? So it will upload these files, and I will say here I am submitting CSV files that represent AdventureWorks data warehouse, right? If I just forget about the spellings, and it will correct automatically. Right. Then I'll ask, can you can you understand the underlying entities available in this data to describe this data set? So these are just prompts, right? This is a application, and these are different prompts, and this will now you can see that certain things which are not available in your chat GPT, you can see certain analysis happens here, right? So it do certain analysis and it does certain calculations. So these are not available typical LLMs, and these are the things what I meant as tools, right? So if now you can see it picks up the content on this data, which is not available in ChatGPT model, and this is purely using the data set I have submitted, right? So if I then ask something like, so once that is done, so I have some prompts, pre-generated prompts, I will take them here. So if I ask now, list top 10 products by sales revenue last year. And this is pretty damn question. You need to do some data processing, right? And this is not directly available, right? So probably you will see it will do series of attempts back and forth to read the data set and perform certain calculations and group data because you need some processing here to calculate the top 10. So while it's happening, I will just go back I will bring in another chat which I have already done this, right? So if you can see on the first attempt, so it has done the calculation like this, but it has only product keys. I mean, if you take any primary data sources, you have product ID, and in your transaction tables, you have product ID and the transaction data, but you don't have what is the name of the product ID, right? So when I again ask, can you cross-reference and see the product name? So it does, right? And even I ask whether you can plot a graph, right? So it does plot, right? The way it does is pretty amazing. So if I go to my, let's see. If you look at this ChatGPT playground, which is not ChatGPT, actually this is OpenAI playground, wrong name usage. So you can see that now together with this playground, these models are now extended with ability to call functions, ability to call interpreters, and also ability to plug retrievers. I will explain what each these. Function means basically you can add, these are currently working with Python, Python functions. So you can, this is just like calling serverless functions, right? So you can define functions together with this OpenAI environment, and based on natural language, you can say, using prompts, you can say, okay, if you have this kind of setup, use this function, right? So you can invoke functions. Let's say you have a ERP backend which is full of REST endpoints, right? And if you can replicate the same signatures, so I'll take a paintbrush here. right? Let's say this is your business APIs, right? So it has its own semantic. So these are the functions or the API endpoints exposed by your existing endpoints, right? And you have this OpenAI ecosystem, which is extended. It is quite advanced than before. So where you have functions, right? Let's say you have functions. These functions are connected to, I would say these are mapped to your natural large language model, so that using prompts, you can say, okay, which function to, given the context, it can detect which function to execute. And these functions are, let's say, connected to your backend, right? Let's say this one is capable of handling CRUD operations for sales, and this one is CRUD operations for CRM, and likewise, right? So very hypothetical, right? I'm trying to visually explain it. So that now, using natural language, simply you can invoke your backend, right? So which was not there before, right? So the previous versions, you have external tools. We had certain tools. I mean, we have done this quite some time back, but now it's native to OpenAI. So if you take I mean, 6-7 months back, we had tools like LangChain, which are capable of doing it, right? So you had this externally, which is not belong to OpenAI, but now, of course, they do it natively. That means it's pretty fast, right? So if you have built this functionality outside your OpenAI environment like this, so you can do that. People like us, we have done that. But it's slow. Like our experience is like if you want to invoke a business functionality using OpenAI, so it minimum take for one single request, it take 5 seconds, whereas our existing OLTP systems, we are talking about milliseconds rate transactions, right? So, but if we integrate in this way, it takes 5 seconds, quite large. So people will not accept it. I mean, it's nice, it's tempting, but of course we have to look at the performance. For of course, for batch jobs kind of things, like nightly jobs, which don't need immediate responsiveness on the front end, you can do that. But when the things are pretty, I mean, responsive, and end user is waiting for results, so we had challenges. But now it has uplift that performance by having these features natively. So you have functions inside OpenAI. Then the second one is interpreter, code interpreter. So given the explanation scenario, let's say I will take example. Let's say you have a data set, right? A simple data set, and I think you all are familiar with Python, generating graphs, generating this scikit-learn kind of machine learning models, which you can act on simple data sets. I'm not talking about big data, but I am talking about, like, okay, you have a simple data set where you want to do some kind of a statistical calculation, right? So that you can explain using natural language. So what these code interpreters will do, so it will generate the underlying Python code to facilitate that natural language explanation. So and it will invoke also, right? So these will invoke and get the results, right? So these functions, these code interpreters are also pretty handy. So now you can generate the scenario on the fly and generate the code, but still it's only Python. I think future they will go for other languages. Today it will Python, but the beauty is, let's say if you want to have your backend, I mean your backend, you have your all backend business APIs. So these are just wrappers, and these are just executors that execute your backend business APIs, right? So it can perform really good jobs, like calculate some mathematical calculations. And these are the challenges you had with large language models. I mean, I can remember when we did like 3-4 months when we did some. I remember some application related to ad campaign planning, like when ad campaigns are going out of order, so we had to do some recalculations, and there was some interesting mathematics. Models were very crazy. I mean, they were, I can't imagine what they generated. So really bad at mathematics, but that problem is no longer, because now the mathematical calculation is done by Python, which is the ideal platform. I mean, for most of statistical mathematical calculations, we have been using Python and R, right? So that's there. And this retrievers, this is the long-term memory I have been talking about. So I will come to that later. So other than this GPT-4 model available outside, so you have large collection of unstructured documents, right? So what we do is, if you upload a file to GPT now, it will calculate the vector embedding of this file, and it will keep a vectorial representation of the model, right? Let's say if you have a large file, let's say 15 MB file, which has data about something, right? And you wanted to query, right? And let's say if you want to summarize, so if you want to find certain information from 20 MB file, right? So if you don't have this vectorizing capability, you have to send them this whole file into OpenAI and ask OpenAI to process it and give what answer you want, right? So imagine the inefficiency. You are sending 20 MB up in the network, right? So the transition time and the safety, data safety, privacy issues. So you are sending whole thing into GPT, and then you ask for a solution, and it will give out, right? So but when you are vectorizing, what happens is you create a mathematical or a vector representation. We call it a dense vector representation inside your vector database. We have a certain set of databases for that. I mean, you can store things like videos, audios, documents, whatever, in a vector format. And then when you ask certain question from this document, what it does is you vectorize the question also, right? So let's say if I ask something about, let's say something, I mean, if you ask something about policies, HR policies, let's say we have a vectorized representation of our HR documents, organization HR documents, and you have a vector representation, and I ask something about my annual leave policy. I ask a question. Then what this systems will do, it will convert my question also into a vector representation. So now you have my question in a vector format, and you do something called a similarity match. So it compares mathematically, vector-based comparison, how similar these question vector and the row vector, and it will extract the highest matching content from the vector database and then turn out it back to the regular text, and you send it over. Now you take a part of the document and send it over to OpenAI, and OpenAI will give answer based on your selected part. So you don't send the whole is it clear? Right. I'll assume. So if you have questions, you can ask it. But I assume you understood. To make sure that you understood again properly, I'll probably I will have a diagram somewhere. No, sorry, I don't have a diagram, but I think it's clear, right? So instead of sending whole thing to OpenAI, you have a mathematical a vector representation somewhere in your infrastructure, and you convert your question also into a vector format, and you do a similarity match, and then you take the certain part of the vector, so which is very tiny compared to the large vector, and then you send it over to OpenAI, right? So you are not sending the vector to OpenAI, so the translation. So yeah, so that is how the retriever works. And for these retrievers, these kind of retrievers, it's not necessarily be I mean, OpenAI for unstructured document. I of course can understand they are using these retrievers, the vector database format. But imagine, so it based on your architectural requirement. I again will take Paint for example. Let's say now we are talking about document, right? But if you take your business architecture, I'll take it like this. So let's work out. So you have your backend systems, large data on your data. It could be SQL servers, whatever the database, right? So it not always you have unstructured data, right? And you want your retriever to work with SQL server, or let's say it's your backend to work with a database, right? So here in this case, what you need is a mechanism to retrieve from your SQL server, right? I'll show you some very good example of what you can do. So what you can do actually in this case, so you get your prompt, your user's input. Let's say he might say, I want to check the sales order status for particular order, right? So he will describe it in natural language. So what you will do is, let's say in this, I'll take a simple example. So let's say you go without API. So if you are doing it directly on SQL Server, which is not the ideal things, but let's try to understand how Retriever works. So you send this scenario to your OpenAI large language model, and you will ask, okay, this is my prompt, user's prompt, and this is my database schema. You will send the database schema also, the definitions, column formats, and everything. And you will ask OpenAI, please generate me a SQL query which I can use to execute on SQL server to given context, right? So that is what you have to do to retrieve this data based on users' requests, right? So that's the retriever for SQL server, right? So I mean, for this you have to do a lot of training. It will not, I mean, it will hallucinate. So I'm pretty sure, I mean, we have tried it, and model if you take GPT Turbo, it's more accurate, but we have developed certain retrievers like this. So it will not, if you directly send this prompt and schema and directly ask from GPT model, it will not give you the ideal. So you have to do certain things, like you have to give more examples. And when you have, let's say, sometimes I remember, sometimes it will calculate this group and some kind of aggregate operations. They're really bad at generating SQL. So in such examples, you can give some hints to OpenAI to generate it accurately. But this is one way of writing a retriever. So this is different from vector database. So you have to design based on your context. You have to design your retriever. Let's say I'll take one other example. It could be even a graph database, right? So I think I had something there. Yeah, this is one of the very earliest prototype we did many months back. So in our organization, we have projects. We have project information. We have CVs. We have customer use cases. We have blogs. So diverse information at different data sources, right? So what we did was we use, I think it's used in Neo4j, we did it. So we built a graph, in-memory graph database, and also the off-sync. That means we persist it as a semantic index. So at given any time, it has a memory representation also, and also like when it is above 2 to 3 weeks, we persist it in a semantic index. So you don't have to like keep everything in memory. So when you have this kind of retriever, graph-based retriever, then a graph engine can be your retriever. So when you get the natural language input into this graph engine, so it converts, it send the context into OpenAI, and it also gives some metadata, because you have to very clearly understand the schemas of these table structures and underlying a lot of metadata. So you have to send that metadata and everything into your OpenAI, and then you ask, okay, what is the graph query I have to use in this case, right? So it will generate the graph query, and you execute, get the data, and present it back to your user, right? So this kind of large number of ways you can do this retrieval augmentation. So this is retrieval augmentation, right? So you retrieve something from your diverse systems in your organization. It could be database, your SharePoint site, it could be your CV database, whatever, right? And you need to retrieve it, and your end user operates in natural language. So you have to write a retriever to, because the data source, it could be operate in SQL or vector or whatever, its own language. But on the end user, he uses in natural language, and you have the large language model which does this translation and avoid hallucinations, and you will generate these queries, and you fetch your data, right? So that is I mean, when it goes to the implementation and the line coding, and it can be very, very complex. I mean, I'm explaining it at very conceptual level. So, but if you look at the deep into these systems, pretty not advanced, but it's complicated, right? So, right, and this is what I meant by the vector representation, right? So you convert your content into word vectors, sentence vectors, and you have a lot of databases which help. Right now, we are in most of the cases we are using Milvas, which is a very good vector database platform, which can use at enterprise level. And of course, for smaller cases, simple day-to-day small size enterprises, you can use something like there's a vector database from Facebook, FICE. We call it FICE index. So it's a standalone vector database. So you can it will not scale at enterprise range, and it will not handle concurrency. But you have to have your own concurrency or orchestration platform if you are using such vector databases. But that's also pretty handy. I mean, for most of the cases. So I think enterprise level still people are not aggressively moving into these use cases. So early hanging use cases are most to do with very lightweight databases. So this FICE kind of platforms has been very powerful for these use cases, right? So I will open up bit of questions before I move into further from organizing committee. If you can track the chat, and if you have any questions, please throw them so I can answer. I'll take 5 minutes to answer any questions. Can you explain what happens after your prompt to LLM? Yeah. Okay. I'll take this question. For if you give a few shots, like I think this will open up for another very very important explanation. Right. If you take LLM, large language model, so you have this neural network with these layers and different neural weights, which is the core, and also we have the attention layer, right? So most of the cases today we are talking about is through prompt engineering. So when you are tuning or optimizing your large language with examples, prompts, scenarios, personas, whatever it is, finally all these things will create a one big prompt, right? So even your chat history, so what will happen is, so all the inputs that you give, it will create something like set of instructions, right? Your prompt will be like if you look at the final generated prompt, sometimes it's like paragraphs, right? So it have large number of instructions how to behave, right? So I mean, outside you may say it's the user message, system message, persona building, human alignment, whatever you say, you will give an instruction, right? So when you take the final intercept immediately before you send it to attention layer, so it will aggregate into one instruction set, right? So that way you are just controlling the focus layer of your application, right? Large language model. So you are not doing anything to your underlying neural network. So you are not changing your weights, you are not changing any parameters, hyperparameters of your LLM. You are physically not doing anything at all, right? So it's just making the focus of your large language model to have a very narrow specific focus, right? So that's why if you go to, like, I don't know, you had a good training yesterday on prompt engineering, but I'm not sure whether these things are covered. I will go. Okay, let me see. I'll open another one because I have to. Yeah, if you go to documentation here, and if you go to something like prompt engineering, right? So if you go here, so there are a lot of tactics you can see here in achieving prompt engineering. That's because now, since we are not, this is just like this. Let's say I will explain this using a very, let's say you are a university trained graduate, right? And if you try to utilize yourself to a, like, let's say, if you don't change your underlying neural network, you are working with your whatever the experience you have, right? But we can get better output by, let's say, this always happens, right? So we have people coming from university, and if I want to get something out from a graduate, so I will prepare work instructions, and I give instructions, and I constantly follow them up and give attention. But your underlying experience and knowledge is fixed, right? Until unless you gain anything from on the job, right? So that way, when you I mean, the way you give prompts for those graduates, right, you can produce two different outputs, right? So that's why you have to have a very strong emphasis on how you do prompt engineering, right? With the same model, same task, your output will be different the way you organize your prompt, right? So if I give very specific instructions to a intern or graduate and guide him with good prompts, so he will produce a better output, right? So, but I am not going to train his knowledge capacity, right? But still I can get different outputs based on the way I give instruction to them, right? It's same with these language models, right? So you are not going to touch anything on the deep neural network. So we will talk about the fine tuning. There's a separate process that you can do, right? But all these examples I demonstrated so far, it's from prompt engineering, right? So I will go very classic example. I mean, in tactics, I have seen that today. So let's say, okay. So if you want to achieve something complex, right? So you can see that this is your prompt. You can see you break your prompt into multiple parts, and right, and then you give, let's try this, right? So you have a system prompt, right? So I'll go to where I can do that. Let's see. Okay, go here. These are tools. Don't worry about these tools I am using, right? But underline, just grab the concept. Later you can familiar with the tools, and also I am not going to tell you anything about the tools. So it's, I mean, you guys are really good at learning things. So if you grab the concept properly, you will understand. I'll take, okay, chat. Maybe I'll use this. Oh, not this one. Yeah, okay. Here in the system message, I just, I'm not doing anything. I took the example in ChatGPT, the documentation, and my prompt is you are an AI assistant, right? So, and you will be provided customer service queries, classify each, and you have some description. And then you have a classification. If the question related to this is how you grab, and it describe different aspects that, right? Then I will, okay, this is right. Okay, then I'll take the other part of the prompt, right? Then the user's question. So based on what user asks, so you have to categorize. That is the this assistant does, right? So simple example. So nothing major, but you will understand. Here I will paste it. Let me see if I have to save anything. No. I need to get my internet connection. Select the probably. So here you have to select this. Okay, save changes. That is what I'm working. Okay. So okay, now if I ask. So it will, I think probably, okay, it categorized. So my question is coming under technical support, troubleshooting, right? If you ask something from, let's say pricing, what is the price for fixing about issue? So now it will categorize my question into different, right? So it's a general inquiry pricing, right? So here in the system prompt, so we have I mean, there are a lot of complex types. So we have broken down the prompt into simple pieces, right? So, I mean, the example I gave here, I think the question was very clear. So, when what happens when prompt engineering, like when prompt comes to these models, so it will first in the attention layer, it will try to break your prompt into multiple pieces. It's same as like when you are given a certain work. So what you will do is you will break, if it is complex, you will break it down into smaller pieces, and you will see whether this can be understood in a smaller pieces, right? In the attention level, I said about something about having 16 different layers, right? So when you broke your prompt into multiple pieces like this, so you can work them in isolation. I mean, so that is what happens in the prompt engineering based machine learning, right? It always map into the focus of your problem, right? Because these models are well trained and they know too many things, right? So it's just like Swiss Army knife, right? So without getting the right focus, so you cannot do efficient work. So right, so you have to narrow down your question or the prompt, and you have to identify what is my subneural net. Hello. So what is my subneural network for this question? So it's matter of breaking the prompt into a minor focus, right? I hope you understood my explanation regarding the question. Any other questions? Right. Yeah, these model details, to be honest, I am not so clear about the internals, very internals of these models. Usually we use, if you go to OpenAI, in most of cases, ADA is a very basic level of embeddings. So I think most powerful embedding is now is let me get the name from OpenAI. It's text embedding. We are using text embedding. Just give a second. Sorry for inconveniences.
Mr. Samudra, we'll be having a Q&A session at the end of the session, so the participants can ask questions by then.
Right. Okay. Okay. I'll drag it into that section. Yeah. But I'll give you answers for that. Right. Let's go to session again. Right. Next, I think I will go into these examples I have created. So let me start with. So these examples I will rush through. So I will just give you the concept. Specifically, I will not spend a lot of time to run this and show you the workings of it because I think we have a very limited time. So the first example is so it's around large language model. I said by design, it doesn't know your internal knowledge. In such situation, let's say if you ask something from 2022 Winter Olympics, right? So in this case, I am using GPT Turbo 3.5, but GPT Turbo 3.5 is cut off from 2021 December or August. I can't remember the exact date. So, but it doesn't have any information related to 2022 Winter Olympics. So, what you will, if you ask that question, it will say, I can't provide that general information because it doesn't understand that knowledge. So what you have to do is, so I created the wiki article content and I created it as a text, and then I created the embeddings from it, right? So you create and then once you give that, so it will give answers. So it will one way is you can like without embedding. Actually, this the first example, you will just together with questions, you send the content. Here you can see the entire text I submit together with question. So, but in this case, when you design a system for this type of architecture, your token count and your overall one is you flood the entire network, right? Because it will slow down the network level, and also your cost for the architecture is too high because it has very high token count, right? So this is possible, right? Together with prompt, you can send your text and ask. So you send the whole thing. I think I mentioned about this at the beginning. But the second approach is to create embeddings. So in this case, I am using a CSV file with embeddings. So here I am not going to create embeddings inside here, but you can see it contains embeddings for these contents. So a CSV file with 2022 Olympic data with embeddings, and when you do that, right, now you can do a similarity matching, and this is what exactly happened. I mentioned it's create a ranking, embedding ranking based on your questions. So you convert your question into a vector, and you do a similarity match, and you create the rankings, how related your question and the content embeddings, and then it will generate the what are the closest matches for. So you can take, I mean, there are certain similarity matchings available, coastline, different distances, Euclidean distances. So you can calculate distance between your answer and the vector, the row vector, and you can generate the answers, right? So this is later I will share these samples. I mean, these are pretty much available, so you don't have to, I mean, I don't even have to share, but I'm just trying to show you the concept, right? So that's done. Then let's go my second example. Let's try to get files. Right. I think this is very interesting one. Data. Let's say 01. Find food review. Files index creation. This example. Sorry. Okay, I'll take this one. This is from LangChain. This example is from LangChain. So if you go to products like LangChain, I mean, I'm just giving you the overall overall picture. If you go to this LangChain library, so one way to work with this large language model is to directly work with OpenAI. So you can directly use OpenAI APIs, and you can work directly with LLMs. But if you look at this LangChain, for example, this does have a lot of building blocks, which I mentioned. Then you don't have to worry too much about underlying way it works. So what you do is you take, for example, so now as I said, you have to for RAG, Retrivial Augmented generation. So you have to support different file types. Let's say you have to load, it could be PDF, text files, it could be your SQL server. So whatever it is. So this LangChain, it does have a lot of document loaders. So you don't have to write this document loading and this kind of building blocks. So you can use existing building blocks and you can use them the way you like, right? So this you can do with yourself. Try to use this kind of platforms instead of trying, like, first you have to learn the APIs, then later maybe like once you are familiar with OpenAI, then I think this will give you very rapid prototyping abilities. So right now, so most of the cases which we have developed last few months, we have been using LangChain as a core platform. So you have these document loaders and also document transformers, and also for embedding. So I think someone asked about that embeddings, right? So when you use these building blocks, you can rapidly prototype this kind of applications, just like plugging Legos, right? That is how we do. And also, like when you embeddings, if you have large embeddings, you have the luxury of using different vector databases, right? So this supports large number of vector databases, this LangChain. And for retrievers also you have so you have this different retriever agents also, like so the scenarios I described are more of very straightforward use cases, but there are some use cases where you need more like chain of thoughts, if you have heard about, like just like how your mind works, like it drives with a thought chain. So when you are given a problem, some of these agents, they can perform complex operations. Like if you take this complex agents like this react, reasoning, and act agents, so it will try so you can see this output. If you look at these outputs, when you give a single instruction, it tries different attempts, right? So it first generate a thought and it performs that thought, and if it fails, it will do another thought, and it then again do another thought. So it runs as a chain of activities we call chain of thoughts. So but this chain of thoughts are more to perform it, like if you want to, let's say if you want to solve a differential equation, can be a very complex work, but using this chain of those kind of agents, you can perform it, right? But it will take time, because it will always try to do some planning and try to do some attempts, and it will maybe even it goes, I have seen that some situations it runs even up to 20 to 30 steps, which is very time consuming, right? Right. And I just have a look at this LangChain. So I am not going to teach you all this. I mean, you can try this out this yourself. If you go here, this cookbook, and if you go to RAG, here you have enough samples. You can just set up your inside the VS Code. You have to just install your plugins, and using this, that's how I do actually. I mean, at least for prototyping purposes, first I'll use this IPython notebooks and just try to play with this LangChain APIs, and then that is how I go about this, right? I will show you another, maybe one example. Yeah, in this example, so I downloaded this Constitution PDF, US Constitution PDF, and then I loaded it using PDF loader. This is a LangChain loader again, right? and then it does a character splitting. So when you do embedding, I think this splitting is a common way of doing it, because then when you are doing a similarity match, because if you do a entire document as one chunk, so when you are doing a similarity match, you get your entire document as a one answer. So that, which is not a good thing, right? So you do embeddings in multiples, and then when you get the embeddings, you can use this FICE. I mentioned about this vector databases, and this is the standalone version of a vector database where you can do it for your own simple experiments, and also mid-size production. I mean, for some systems we are also using FICE, but then you have to do your own orchestration framework, because these are not concurrency supported. So when you have a large number of requests coming in, this will not work as expected. And then you can save it, the vector database, you can save it, and then you can load at any time, and you can then you can ask retrieval questions from that vector, right? And then you get the results and you print, right? So I ask, so from this, what do you have in the section 2, right? In the section 2, it says, okay, article constitution stress on. So it gives the proper answers, right? So and also, I mean, you have to do a lot of, I mean, this example for straightforward hello world scenario, you will get these kind of answers. But when you do, let's say, I can remember, like when we had to do large implementations with bulky text contents, we had one of our client had a very bulky help system, which we actually did like web scraping, and then we created this kind of a vector where we can ask questions, but our original documents were not written in a nice way, right? So when you have your source document is not so creative, if you try to get very creative and professional looking answers, that also will be a very challenge. So right now, one solution we are working on. So in such situations, you have to write several layers on top of that to make things more creative. So it's not matter of you just put your documents into vector database and just get answers, right? So you have to have some kind of intermediate ontologies to, and so one situation I can remember, we mixed graph and vector. So in the graph layer, you had a very nice like router kind of setup where you get the subsection of the document, then you fetch from the vector, right? So you have to do a lot of architectural changes, not this kind of hello world kind of solutions, but that's a different level, like when you go to production level setups, right? And then I'll again go probably, okay, this is also very interesting stuff. So this is SQL generation, right? So I have a SQLite database with some data, and then we have a DB chain, right? So we SQL database chain. This is also coming from LangChain, where you can connect a SQL server or SQLite database, and you can text to SQL driver, right? So you can see when you ask the question, it converts into SQL, right? So that conversion done by this LangChain driver, right? So I remember we wrote this ourselves purely using OpenAI, and then we use this DB chain driver, right? So sometimes our manual work paid off. That I can very clearly say. I mean, these are designed for general purpose. Sometimes these drivers doesn't work as we expected, especially when you have very I mean, traditional DB structure and your own naming conventions, and you have a lot of tables and structures, very legacy kind of databases. I found it very difficult, this SQL DB chain, but in that case, we had to go very manual approach. You can see, so it generates quite good results, right? And even I think I have one example where you generate even chart. I think if you go further down, yeah, it generates. So this Retrivial library, it can generate Python code. So what I did was you generate using SQL driver data, and then the Retrivial driver you generate the Python code. So it generates the chart, right? So this Python can be very, very powerful tool in achieving this kind of thing, right? So let's see what else I plan to do. Adventure works I did. I think one important one probably, yes, that's, let me close this since you saw it. Okay, open AI. Let's see, I think something is missing here. Okay, this one, yeah, retriever, yeah. Okay, right. This OpenAI, probably some of you have seen this. So there has been a lot of drama around OpenAI lately. But if you go to OpenAI, now they have this new API called assistants, right? So this is very powerful, API. So if you, so I have created this assistant, right? So basically, this is the one I demonstrated. You can attach functions, code interpreters, retrievers, and files and everything, right? Suppose if you want to insert a file into OpenAI without using none of this, you don't use LangChain, you don't use any other custom made tools, but you want to get it down directly from OpenAI. So this is a possibility, right? So what I did was I attached this sales data sample. It's a CSV file with sales data, right? And I ask it to perform a exploratory data analysis, right? So, and it start generating these different Python codes, and it start calculating all this, and finally you can see how, I mean, I asked it to generate 10 different charts, right? And it does it, right? So just to analyze this data set, it can perform. So I mean, this is in a way, this is very fantastic, right? So you can see day by day, you are bringing a lot of power into these platforms. So you can generate things in advance on the fly using these models. So it's not very much magic anymore, right? So, and it's very easy to understand, so you don't need a lot of knowledge, but of course you have to have a sensible thinking around like what tool to pick, which how you break things down and things like that. But you can see the outcome. I mean, traditionally I can remember when I get a AI workload, so usually on the data set itself, this feature engineering and exploratory analysis itself takes certain period of time, and it's a very time consuming, very tedious process where you have to clean the data set and look at initial statistical patterns and understand these different correlations and feature extractions. Probably if you have heard about things like principal component analysis, feature analysis, so very tedious jobs, and it's the market for typical data science people, right? So I mean, if you are familiar with this data science degrees, so it is kind of a dream job. I think highest paid job by as for Forbes, if I'm correct, in 2014 this is named as highest paid job, and it's a dream job, right? So it's a highest paid job, and today now we are talking about that job is automated, right? So what you are seeing on the job is the data science scientist job, which is automated, and you can do, like, if I sit for one day with the data set, so basically I think I can really perform something which took 2 weeks, 3 weeks by data scientist on a single day. If I focus and do it, I can do it, and I have done it several times. So I don't keep data scientists anymore, right? So so you can see the good and bad side, right? So, and that is why this is really important for you to have a very clear understanding where you are going to work, right? So that you have to plan. Don't plan for jobs like data scientist anymore, right? So that job will not be there. So if you are to do statistical analysis, so this will automate data scientist job, statistician job. So those are, I mean, specialized knowledge but routine work, right? If you are to do a feature engineering job for 20 different projects, if you take 20 different projects, your work that you are doing is routine. It's only that you have a specialized knowledge, but that now this model has that specialty, so there's no big magic. So if I mean, I'm also from statistical background, but today if I am to say, okay, I have a specialist and I know statistics, no value at all, right? Because these models are doing it pretty damn good than me. I mean, sometimes I see that, okay, feature engineering patterns which I cannot guess, these models are suggesting, like you say, okay, do this, and I mean, you should be able to manipulate this tool, but don't try to be that data specialist, and don't dream about those kind of jobs. So that you need to clearly plan where you are fitting and what you are targeting. Plan that. I mean, for us, this is a really luxury. I mean, that's because now we have a stable job, right? So, but for a youngster, so this is a good thing. Yes, it's magic, fancy, and it looks nice, but of course there's a threat which is happening, right? So this playground is the visual environment, right? So whatever the things I did I mean, I uploaded this file here, then I switched on code interpreter, I can switch on these retrievers, right? So whatever things I do here, and I can design a nice prompt to analyze these files, right? So these things you can directly manipulate inside code. So you don't have to come here to do this. So you can pretty much automate this whole thing. So that's what I have done here, right? So this retriever example. So this is a retriever plugin, and this is my prompt. And then I describe, and then I attach my file somewhere here. Probably I have. Oh yes, this is the file upload function, and so I have designed code interpreter function. So I have designed few functions here, and then I do a file upload, so question and answer file. Then I code interpreter. So then I ask some questions. Okay, then what did I ask? Can you tell me about the coverage of a home insurance policy? So this is the insurance document that I uploaded, question and answers. So it gives them answers from that file, right? So that's interpreter, right? So it use that. Let me see. I have another. Prompt. Yes, this one. So same thing. So you can see this is the same graphs that you saw on the site. So I did it programmatically. So this is my prompt, right? So so you can see the prompt engineering. I said something about that breaking down large prompts into simple tasks. So this is what it, right? So I have the clear prompt, and I have very clear instructions on what chart to generate and what should it look like. And when you do all these things, so it generate the Python code and it runs it and create here you can see there are a lot of images that it has generated. So below you can see once I run it, so I access those generated images and display it here, right? So if you inside your application you can do this, right? And if you want to generate let's say interactive charts, so this is the Python this plotting libraries. It uses what is that plotly.js or plotly, right? So but if you want to generate more interactive charts, then of course you in your front end you can do it, generate it using JS libraries and modern this high chart kind of libraries, and you can design this very interactive dashboard. So I mean, for commercial reasons I can can't share it, but today we can using a single prompt, I can simply generate entire dashboard. Like let's say if CEO wants to analyze certain data set, so he can just say, okay, generate me a dashboard describing this. So you give the prompt and your dashboard is coming out. So we have done it. So not rocket science anymore. Yes. What else? I think. Yeah, I think good to go for Q&A session. I mean, overall, I didn't plan to give you like this how to like how to code and things like that, because I think at least I gave you a very high level coverage about the architectures and RAG. So to summarize, RAG is for like these LLM models. By design, they have their own knowledge, but they are not aware of the rest of local knowledge. So we have to augment that knowledge using different architectures by submitting either unstructured data or business data. or other means of integrations. So there are ways you can do that. One common way of doing it for unstructured data is through this vector databases and this embedding approach, where you embedded the large local knowledge into vector database and do similarity matching before you talk to OpenAI. So, but if you are to extend more into like SQL database API, so you have to write your own drivers, which does that, which we call them as retrievers. One way is to use retrievers. Another way is to use these interpreters. On the fly, you generate code to perform backend integrations using compilers. So that is the second way of doing is, if you look at the latest version of OpenAI, it supports all these protocols through API level. So you can create a lot of interesting prototypes, but still I haven't so many prototypes using this modern because I think there are certain challenges still. When I look at, we did some implementations using this GPT-4 Turbo 3.5, this version, the preview version. We found some issues. Actually, we reported them, but still, I think they prematurely released certain models because they were in a hurry. I think that is one of the reasons that they have this clash also. But I think very clear they have the required architecture in place. So I think in time to come, this will stabilize. But I haven't seen many production level people are using this. This is still preview. You can see it's a preview model, but very powerful, right? So it's even though it's preview, I think it's state of art. I mean, they have thought through the real enterprise level integrations. So no doubt, architecturally, I think they are very strong. Only matter that they have to spend more time before they make it commercial. But that will happen. I think now Microsoft also pushing it really hard. So this will be part of all the co-pilots. So yeah, any questions? I think the previous question about ADA 2, that's correct. Text ADA 2 is correct. Since the day OpenAI latest API package is not compatible with language. Yes. So this is a very massive challenge, and that is one of the reason I have this partly working. So my experience is, if you are to work with LangChain use cases, you have to be with. So I'll show it. So very easy. So I have this. You can see that. So I have configured two Python environments, right? So this old Python environment, it's filled with OpenAI 0.27 and the LangChain older version, right? So those versions are pretty much stable together with LangChain. But if you take the latest version of OpenAI, whole system sucks. It's most of the systems that we have been designing are now breaking, but they will fix it. So those are not backward compatible, and most of the things, if I do pip upgrade, almost all the systems will fail, right? So we haven't done it, but at least for my prototypes, when I try this offline, so we on the commercial systems we don't have this latest version of OpenAI, so I think it will take some time, and I'm pretty sure LangChain will not give you the latest versions pretty fast, because I think most of the LangChain functionalities now are at OpenAI as native mechanisms. So I think people will think twice whether to use LangChain or not. Right? These specifically loaders and I think loaders and transformers people will use because those are very useful. But others features are available already in OpenAI. If you go to OpenAI Studio, for example, they have a concept called prompt flow and prompt chaining. It's a no-code approach to configure complete end-to-end large language. I mean, you can plug multiple large language models, different models for different work, and you can basically configure a chain and invoke it, just like we do workflow chaining. So those tools are very powerful, and it's I don't have time to show you. We are using it from flow, and it when you use those no code tools, I hardly think why we need LangChain kind of things for commercial work. But certain things, of course, we need to use, like very handy, like these loaders, specifically loaders for PDF loading, SQL loaders, and some chains and tools. They call it agents. Those are partially being implemented at OpenAI, but quite fast Microsoft will have those tools, everything written into platform, because I think you cannot compete LangChain with Microsoft. It's a budget game, so it's how much money you have. Finally, it will end up in Microsoft. But yes, now at the moment, at least this short period, I have seen that most of the tools are broken. Platforms are. How would you handle keeping data in multiple? Yeah, I am not sure I understood the question very correctly. At least I hope this is the question you have. Your existing systems may be written using different languages, right? But if you look at these functions, large language, OpenAI functions and code interpreters, in most of the situation, I would use them as wrappers. That means I am not going to touch any of the existing business systems. So they will be on their own language. But what you do is you will just invoke those functions or APIs from this side. So there's no need to I mean, I don't know how long it will take Microsoft to think about code interpreters using C#, because I think if you take languages like Python, they are pretty much powerful in maths problem solving, right? So what's lacking for large language model is maths, right? So that's why they have brought Python interpreters, but they are not trying to build business functions into languages, right? Language models. So they will be use it as a wrapper, right? So that's how we do it. Yes, Google Colab, you have plenty of ways you can. I mean, if you go to LangChain, I think you have direct Colab files you can open up. So no issue, Colab, you can use it, and you can install this the dependencies. So I also have done it. So it's okay to use it. Maximal marginal relevance. To be honest, I am not familiar with this. Sorry. So probably it's another similarity distance vector calculation, but maybe it's more optimized. But I haven't gone into that details, to be honest. I have used fast system for 4,100 PTM, but LangChain, Pinecone, GPT for now it's LangChain Amplify. Slow. How can I enable web retrieval scroll? Website ask question. Panduka, I can help you out. Shall we take this offline? You can just buzz me. I mean, so this performance issue with LangChain, it's to do with now in LangChain agents. Most of the agents they have chain of thoughts concept called chain of thoughts. So in the chain of thoughts, it's matter of you try one thought, and if it fails, you try next thought. So it's process of chaining your thoughts. But there's a concept called plan and execute for most of the scenarios that are not effective in LangChain through this chain of thoughts. What we did was we exactly try to stop their thinking process. So what we did was instead of LangChain tools, we created our own tool chain, right? And also we created our own planning function. So there's no I mean when for a specific cases, in the most of the specific cases in advance we know the exact steps we have to perform, right? So but when you don't know the exact steps, then it's okay to you go through this chain of thought kind of scenario. But in most cases what we did was we created a plan and execute approach, and we bypass LangChain. Instead we created our own tool chain. In our own tool chain we have very known business rules, right? So there's no thinking process and try out process. Instead we clearly say this is the plan and these are the tools, and you have to perform as per our plan, right? So LangChain, the issue is it does its own plan and it slow downs, right? It's pretty slow, right? So the way is replace chain of thoughts with plan and execute, but sometimes you need to do chain of thoughts. I'll bring you examples again. We generated this SQL generation from natural language. In that situation, sometimes it hallucinates and it generates wrong in SQL. And then what we do is we execute the generated SQL, and then the SQL server will generate an error, right? So we feed that SQL back to model and we re-execute. So it's kind of a thought chain and execution chain. Other than that situation, we always try to avoid LangChain way of working through chain of thought. We switch from plan and a chain of thought to plan and execute. Just did I answer your question? otherwise you can reach me. You can reach me, and we can have a very. I can help you out for the issues you are having. How is the yes, yeah, evaluation and testing of LLMs. So we take this at 2 levels. So we like traditional LLMs, we don't test for this performance parameters or this. There are certain curves, like whether the model is overfitting, underfitting, and what is the accuracy curves, things like that. Rather, we try to, so the initial set we have given to the production, we design the system in a way that at least it will give 80% of accuracy. So if you look at, if any machine learning or LLM based model will not be 100% accurate, so we go with that decision, and these are assisting tools, so that you cannot even giving 80% assistance, that is good enough. But certain tasks, if you take, you cannot say SQL generated query is 80% accurate. So those things we try to improve the accuracy through giving more examples, right? It's not that we try to generate 100% accuracy or check model parameters. I think we are not yet matured enough. I mean, it's same for all the industries to measure the accuracy of LLMs. I mean, from language model vendors, they have their own publications regarding accuracy parameters and how powerful they are, like whether they can sit for these exams and whether they are powerful than humans. Those kind of data are there. But generally, first level testing is based on the task we pick, whether to go with models like GPT 3.5 or Turbo. That is one decision we take, right? And also whether we should check more Da Vinci format model or very less powerful format on the pricing level. Thereafter, we check the business level functionalities, whether they are accurate, and then we decide. Not that we look for the language model is working fine, but if we can test the business functionality and if it is accurate enough, that is the test we are doing. So far we haven't gone into LM level testing. Yeah, you can contact me on LinkedIn. So I'll stop sharing my phone number. So because I mean, yeah, I can share my phone number, but I work with some business schedules also. So maybe for through organizers level, if you have any other questions, we can have another session, like you can collect some questions and things like that by organizers. Then we can plan another session later if you have more questions and if you want to understand the subject more deep. Otherwise, you can reach me from LinkedIn. What are the very interesting question? I would say one of the topmost skill you have to have is prompt engineering. I mean, technically, I know the people who are coming from A-level maths and after doing a degree program and all this. I mean, we have cycle of education cycle, right? And we have a guarantee that, okay, from this education system, you have a person who can code that. Then learning about APIs and these models, I think those are, I mean, definitely you will be good at it. But prompt engineering, I would say it's more than 50% of the game, right? So even if I know the architecture and model correct, but if I don't have the proper prompt engineering abilities, I mean, today if I have a system to set up, even in the coding and the solution, most of the work, it comes through prompt engineering. I mean, it's even I can ask how to give a solution from the language itself, but itself, if you just ask a simple question, system will not give you a correct answer. But if you have a very strong prompt engineering skills, the level I am competing, it's a very tough challenge. I mean, that level of prompt engineering, it's not about your English or articulation ability or your language usage, but how to break things into pieces and using these different tactics. And if you, let's say, if you are to generate sample data set, and if you are to generate sample feature engineering process, so very tough jobs even in prompt engineering context. But if you can master prompt engineering, I would say it's number one to achieve. So it's very important part. Then the building blocks. I mean, what are the key building blocks to build up this kind of solution? Because now everything else, the coding and low-level work, it's you can auto-generate, right? So if you don't know how to generate these things and solution, I can imagine, like last 1 year, the knowledge I got through this prompt engineering and generating abilities, I cannot even match for my last 20 years of knowledge. So it's that wide. That's only because of these large language models I have become, I mean, maybe 10-15 times productive person than who I am, right? So master prompt engineering and use LLMs as much as possible. But also, like, I mean, it's different from the person with my age, because I think we have come across all the hard work for learning coding, and even myself, I have wrote assembly code. So I think programmer wise, I think I have mastered it a lot, but your situation is completely different. So you all are new. So you have to also balance it out. I mean, programming itself also bring you some shape into your mind and your skill set. So you have to balance it out and make sure that you also keep in par with that programming skills. Because I mean, I can very easily say, okay, now I can auto generate code, but I think people in your age, I think it's I shouldn't advise you to not to code. So spend coding time, that is important for your abilities. But for complex situations, if instead of Google searching, going into Stack Overflow, if you can use prompt engineering and try to solve it, no, but still you code yourself, but maybe solution you generate using LLM. So you have to have a very good management, large language model management abilities. So it's a must. Any other questions? Yeah, LLM actually it doesn't see the structural data. So if you look at all my retrieval examples, what I did was I generated a query that can handle tabular data or the structured data. So in the case of if you take SQL server, data in the SQL server, so language LLM generated SQL, but it doesn't look at data. So your data it process of the LLM. So it runs the query inside your area. It's outside LLM, but I generated the instructions, SQL instructions, SQL query. In vector also it's same, right? So you offload your vector similarity matching. It doesn't happen inside LLM, but once you generated the match, then you send the match and get an answer. So LLM doesn't see actually structured data or large data volume. So it process outside the LLM, but LLM, what LLM does is it handles a smaller workload. Either it generate the retrieval query, and there are retrieval handlers outside the LLM, which does the real data integration part. Yeah. Okay, with that, I think I will just, I mean, I will not take a lot of time from you. It's Sunday, almost 9, and I really happy to see you all like a young crowd staying late Sunday evening. But I mean, so I'll be doing more and more of these kind of sessions on and off. So let's see. I mean, if you are really interested on this area, so you will hear more and more cases. I mean, I have been doing this at a very ad hoc phase last few months, but now I think I did few, and there are a lot of demands from people. They wanted to learn this and also wanted to see insights. So I will keep doing these kind of sessions, and so probably you may also come across. So let's see. I mean, this is moving at a very fast pace. I think even in next 1 month or so, what we have seen so far will completely change. So let's see how I will share my knowledge, so you will get in touch in LinkedIn and other places. And if yeah, so probably we will meet probably in the final hackathon day. I'll be there, so we can, some of you may get a chance to have a more discussions. Let's see. Okay, with that I'll wind up. So thank you for the participation and all.
Ladies and gentlemen, we hope you have gained valuable insights. Our explanation of retrieval augmented generation and fine-tuning large language models has illuminated the incredible potential of technology and artificial intelligence. A special thank you to our distinguished speaker, Mr. Samudra Kanankearachchi, for generously sharing his expertise and insights with us today. Your contributions have enriched our understanding of the technological landscape and the boundless possibilities of AI. We sincerely appreciate your time and commitment. Mr. Samudra, please accept this token of appreciation.
Thank you very much. It's a pleasure.
Before we adjourn, let's capture this memorable moment. To all participants, kindly turn on your cameras as we prepare to take a group photo to commemorate this engaging session. Your presence has given this event its vibrancy. We trust that today's session have ignited your curiosity and expanded your knowledge. Stay tuned for the third session of the AI Bootcamp happening on 2nd December, where we'll delve deeper into training and deployment strategies and front-end implementation. As we conclude, we wish you all a wonderful evening. Stay curious and stay connected to the ever-evolving world of technology. Have a fantastic day. Thank you.